I'm Dan Sweeney from MathSpec Incorporated. Our company has developed software to help chemists identify unknown molecules from accurate mass fragmentation data. Our software generates simple models of molecules from mass spectral data. This is done using accurate mass fragmentation data and mathematics. We then use these models to help identify unknown analytes. Unlike NMR and IR spectra, where individual substructures of a molecule can be characterized by their frequency, the masses of individual fragment ions in a mass spectrum are not usually characteristic of specific substructures. Each fragment ion mass must be interpreted in the context of other fragment ion masses in the spectrum. To do this, the mass spec approach is to use partitioning. Each fragment ion in a mass spectrum could be viewed as composed of one or more subfragments. Subfragments are groups of atoms that tend to stay together when a molecule breaks apart in a mass spectrometer. A partition is a group of subfragment masses that sum up to the mass of the precursor ion. To illustrate this software application, I will use a spectrum that was provided to MassBank by Emma Szymanski's group at the University of Luxembourg. First, we need to find the masses of possible subfragments. We calculate these subfragment masses using simple addition and subtraction. Our partition software adds together combinations of subfragment masses to find groups of masses that sum up to the molecular mass of the precursor ion. These are mathematical partitions of the molecular mass. In a typical data set, there are usually over 1 million partitions of 3, 4, or 5 masses. We then calculate the masses of every subset of the masses in each partition. The best subsets will sum up to the masses of the most intense fragment ions. This is the top scoring partition derived from the fluconazole spectrum. Often, subfragment masses may correspond to multiple subformulas, as shown here. The molecular weight error is the difference between the mass of the individual formulas at the bottom half of column 5 and the sum of the subfragment masses. Fluconazole has the formula C13H12F2N6O, third row, and an error of 0.1 millidaltons. Two other formulas have the same error, but note that in the last column, the C11H21N3O3PS formula has a subfragment error of 2.5 millidaltons. This SF error is the sum of the absolute differences between each subfragment mass and its subformula. So this formula is much less feasible than the other two. Now, for many studies, for example identifying reaction byproducts, this is as far as this data can take us. With this new version of our partitioning software, we generate partitions and possible subformulas independent of any database. In some applications, such as environmental chemistry, the spectrum might be that of a known compound. Many of these known compounds are found in the massive Pubchem Compound database. We can search the massive database for any compounds that have essentially the same molecular weight and that also have a molecular structure that can be partitioned into substructures with corresponding masses. As shown previously, a single subfragment mass can match multiple subformulas. The correct formula and subformulas are often difficult to determine, and so we use subfragment masses for searching Pubchem Compound for matching molecules. Note that the corresponding substructure masses, for example 68.0249 Daltons, may vary in mass from the corresponding subformula masses by the mass of an integral number of hydrogen atoms. By opening the file of the most relevant compound, we see the printout of how PCID 3365 matched the first partition. PCID 3365 is fluconazole. Mass spectral data is always ambiguous, so relevance is very important. Other factors are the number of partitions that match the molecule out of the 10 best, the mass difference, and the number of bonds disconnected. The experimental isotopes were calculated here. Thank you for watching this video.